Hello friends, so today we are going to discuss a book named Physics Fundas written by Karan Dasani, and we have reached its fourth lesson, a fourth chapter, that is work, energy and power. Work, it is a very familiar word as we use it regularly in day-to-day life. Normally we define any activity done by us as work. But in physics, the definition of work is totally different. In physics, work is said to be done if an object makes any displacement under the action of force. Hence, in physics, for work to be done, the object must move. Now, by considering the direction of displacement, we can divide work as the work is said to be done by a force if the point of application of force moves in the direction of force. But if the movement is in opposite direction, work is said to be done against the force. So mathematically, work can be defined as W is equals to F dot D. The unit of work is Newton into meter or Joule. As shown in figure, a block is kept on an inclined plane at an angle theta. Now, if we apply a horizontal force F on the block, then the block moves on the inclined plane. Hence, work done W is equals to F dot D. That is, W is equals to Fd cos theta. Though both force and displacement are vector quantities, still work is scalar quantity due to the scalar product. Work being is a scalar quantity, can still be positive or negative depending on the angle between force and displacement. If theta is greater than or equal to 0 and less than 90, work is going to be positive. If theta is greater than 90 but less than or equal to 180, work done is going to be negative. But if theta is 90, work done is going to be 0. In thermodynamics, if work is done by the system, then it is considered as positive. That is, if air comes out of the balloon by itself, and if the work is done on the system as work is negative, that is, to blow up air in a balloon. Energy. Energy is the capacity to do work. The unit of energy is also joule. Kinetic energy, potential energy, electrical energy, heat energy, nuclear energy, chemical energy are the examples of the different kind of energies. But there are two kinds of mechanical energies. First one is kinetic energy. The energy possessed by any body by virtue of its motion is known as kinetic energy. So, the kinetic energy is a consequence of motion of any body, and any body at rest does not have any kinetic energy. Kinetic energy equals to 1/2 mv square, where m is the mass of the object and v is the velocity of the object. Potential energy. The energy possessed by an object by virtue of its position or elevation is known as potential energy. Hence, this type of energy is due to the position of the body. So it can be said that a body at rest may possess potential energy U, where U is equals to mgh, where m is mass of the object, g is gravitational acceleration, and h is height of the object from the surface of the earth. The sum of the potential and kinetic energy is known as mechanical energy, which is denoted by capital E. So we can say that capital E will be equal to capital K plus capital U, where E is mechanical energy, K is kinetic energy, and U is potential energy. Law of conservation of energy. Energy can neither be created nor be destroyed. Only the conversion of one form of energy to another form can take place. So the total amount of energy in the universe remains constant. That is, in a hydropower station, we store water at a height. So the water possesses potential energy. Now, when water falls on the turbine, the potential energy of the water is converted into kinetic energy as the water is in motion. Now, as the water falls, the turbine starts rotating, and this rotary motion gives us mechanical energy. Further, this mechanical energy is converted to electrical energy, and hence electricity is produced. So we didn't created any energy. We just converted one form of energy into the other. Comparison of work and energy. Work is the movement of an object by a force, while energy is the capacity to do the work. Systems can never have any work, but it can have the energy. Work can divide as positive or negative based on the angle between the force and the displacement. Energy is of various forms like mechanical energy, electrical energy, nuclear energy, etc. If an object does not move, that is, it is at rest, it is said that no work is done. But if we talk about its energy, its kinetic energy is zero, but it may possesses any other energy like potential or chemical energy. Power. Power signifies that how fast the work can be done. Power is defined as the rate of doing work. That is, power is equals to work done upon time taken. So P is going to be delta W by delta T, where delta W is work done and delta T is time taken to do that work. The unit of power is joule per second or watt. We can also say that P is equals to F dot V, where P is power, F is force, and V is velocity. One notable thing is power is a scalar quantity. Another unit of power which we generally use to rate the engines in horsepower is 1 HP is equals to 746 watt. And one another energy that we guys are using in day-to-day life in electrical meters, we get the bills in terms of units, where this 1 unit simply means that 3.6 into 10 raised to 6 joule. If your consumption of electricity is 1 unit within a 1 hour, that means you are absorbing, or your house is absorbing, the energy of 3.6 into 10 raised to 6 joules within a 1 hour.